Hello viewers, welcome back to my YouTube channel. In this video I am going to discuss about the fabrication process in VLSI and the introduction to VLSI fabrication process. VLSI involves the creation of integrated circuits with millions of transistors on a single chip. The fabrication process in VLSI plays a crucial role in determining the performance and functionalities of electronic devices. It involves a series of steps to create the intricate patterns and structures on a silicon wafer. And the silicon wafer preparation. The fabrication process begins with the preparation of a silicon wafer, typically made from a single crystal silicon ingot. The wafer is polished to achieve a smooth surface and then cleaning to remove any impurities. A layer of silicon dioxide is often grown on a wafer to serve as an insulation layer, and the photolithography is a key step in fabrication process where patterns are transferred onto the wafer. A layer of photoresist is applied to the wafer, exposed to light through a mask and developed to create a pattern. This pattern defines the location of the various components on. And etching is used to selectively remove materials from the wafer to create the desired patterns. There are too many types of etching: wet etching, which use liquid chemicals, and dry etching, which uses plasma. Etching is crucial for define the shapes and dimensions of the components on the chips. And the next deposition is the process of adding thin layers of materials onto the wafer. A common deposition technique includes chemical vapor deposition (CVD) and physical vapor deposition. It's also called PVD. Deposited materials can include metals, insulators, and semiconductors. And the implantations. Implantation is used to introduce dopants into the silicon wafer to alter its electrical properties. Dopants are ions of specific elements that are implanted into the wafer at precise locations and depths. Ion implementation is essential for creating the transistors and other electronic components on the chips. And the metallization involves deposition metal layers on the wafer to interconnect the various components. Metals such as aluminum, copper, and tungstens are commonly used for interconnects, and the metallization is crucial for creating the conductivity pathway that allows signals to flow between components. And the planarization is the process of creating a flat surface on the wafer to ensure proper layer to layer alignment. Chemical mechanical planarization is a common technique used to achieve a smooth and uniform surface. Planarization helps to improve the reliability and performance of the integrated circuits. And the annealing is a heat treatment process used to activate dopants and repair crystal damage and relieve internal stress in the wafer. Rapid thermal annealing and furnace annealing are two common annealing technique used in VLSI fabrication. Annealing is critical for ensuring the proper functioning of the transistors and other components of the chip. And the inspection and testing. After the fabrication process is completed, the wafer undergoes inspection and testing to ensure quality and functionality. Various techniques such as scanning, electron microscopy, and electrical testings are used to validate the integrity of the chip. Defective chips are identified and discarded during this stage to ensure only high quality products are shipped. And the packaging. Once the chips are deemed functional, they are packed to protect them from external elements and provide electrical connections. Packaging involves encapsulating the chips in a protective material and adding LEDs for external connections. The packaged chips are then tested again before being shipped to customers. And the advancement in VLSI fabrication, advances in technologies and has enabled the fabrications of smaller and more complex integrity circuits. Techniques such as extreme ultraviolet lithography and 3D integration have pushed the boundaries of VLSI fabrication. These advancements have led to faster, more energy efficient, and higher performing electronic devices. And the challenges in VLSI fabrications, managing the increasing complexity of fabrication process requires advanced simulations, modeling and control techniques. VLSI fabrication also faces challenges related to cost, time to market, and environmental impact. And further future trends in VLSI fabrications, the future of VLSI fabrication is likely to be driven by technologies such as artificial intelligence, IoT, and quantum computing. The industry is expecting to continue innovative to meet the growing demand for faster, more efficient, and secure electronic devices. And conclusion, the fabrication process in VLSI is a complex and intricate series of steps that enable the creation of advanced integrated circuits. Continuous innovation and advancement in technologies are driving the evolution of VLSI fabrication. Understanding the fabrication process is essential for engineers and researchers working in the field of semiconductor technologies.